Hi, welcome to my video on growth problems, and this growth problems are related to doubling. Doubling rate. Growth is, think about growth as the base equals 1 plus the rate. Growth is great, the base is greater than 1, so it's 1 plus the rate. If you have an increase of 100%, then it's 1 plus 100%. And 1 plus 100% is 1. If you think about it, 100%, you move your decimal from here 2 places to the left and you'll get a 1. And 1 plus 1 is 2. So when you have a 100% increase, you have a base of 2 in an exponential function. The base for doubling problems is 2. Doubling, 2. The equation for doubling is y equals a, base is 2, and it's the time that is elapsed over d, which is the doubling time. So d is the same as your c, the increment change. Let's do some problems. Number 1, 700% invested in an account and doubled every year for 4 years. Find the amount after 4 years. So A is $700. And doubling, so your base is 2 and is doubled each year, so your doubling time d, which is your c, is equal to 1, and your time is 4 years. So you have y equals a, and again it says doubling, so if you go b is t over c, so your equation is y equals a 2 t over d. So a is $700. Doubling is base 2. Your time is 4 and is doubled every year. So y equals 700. 2 to the power of 4. So y equals 7. And 2 to the 4 is 16. And 16 times 700, that's a 7, I said 700 is $11,200 and it's dollars. Number 2, a population of a town doubles every 6 years. What will be the population to the nearest thousand in 30 years if it is now 23,000? So it says doubling, so that means doubling. So that says that my base is 2 every 6 years, so your doubling time is 6. What will be the population in 30 years? So t is 30 and a is 23,000. So y equals a, doubling time is 2, so it's t over d, so it is 23,000 is doubling, which means the base is 2, and your time is 30 years, and your doubling time, it doubles every 6 years. So you've got 23,000, and it's being doubled. So if it's 30 years and it doubles every 6 years, that means it's doubling 5 times. So you got 23,000. 2 to the 5 comes out to be 32. And when you multiply 23,000 by 32, you get 7,000. You get 736,000. 736,000. And again, you could have plugged this in your calculator, but it's easy just as well to say 2 to the 5 is 32 and then multiply. Or you can plug it in your calculator, go 23,000 bracket 2 and a power of 5, and it works out to be the same. Okay, that's in relation to doubling time. Now I got an extra question here, not related to doubling, but just a little question, a little bit different style. An employee of a company is offered $40,000 salary package for 12 years. So which one is better? Is he going to pick A, B, C, or D? And the reason I'm doing this is because the 10.3% every 6 years. So he's going to get 10.3% every 6 years. So your formula, or let's look at up here, A is, you're going to start off with 40,000 and the time is 12 years. And in this one, this is true for all of these questions, and your rate right here is 10.3%, and your C is not a doubling time, your C is every 6 years. So notice you get 10.3% every 6 years. So Y equals A, 1 plus your rate, and your time over C. So what's going to be your salary? So you have $40,000, 1 plus your rate, which is 10.3%, and your time is 12 years, and your increment change for C is 6. So you get $40,000, and 10% is 0.103. 10.3%, the decimal moves 2 places to the left, become decimal 103, and it's for 12 years, but this percent is for 6 years, and then you get 10% for the next 6, so that's happening twice. So that's $40,000 at 1.103, and it's happening twice. And if you put that in your calculator, you'll get 48664. Okay, what about this one? So will he take that one, or will he take the 7.5% every 4 years? And again, the rate is 7.5%, and your C is 4 years. So the formula is Y equals A, 1 plus R, and it's T over C. So $40,000, 1 plus 7.5%, and the time is 12 years, but it's happening every 4 years. That's your C change. So you got $40,000, 1 plus 7.5%. Well, 7.5% is 7.5%, which is 0.075. So notice I changed the half to a decimal. A half is 0.5. Now I change a percent to 0.075. That's what I do. And it happens. So if it happens every 4 years, it means it's going to happen 3 times. So that's $40,000, 1.075 raised to the 3. And when you put this in your calculator and work it out, remember, you can take 1.075 and cube it and then multiply by 40,000, or sub this in your calculator as it is, and you come out to 49692 to the nearest dollar. So notice the percent is less, but it's being done 3 times. This percent is less, but it's done again 2 years. That's 6 times. So let's look at this one again. Don't forget, you can pause your video and work these out before I do. And the increment changes too. So Y equals A, and 1 plus R with T over C. So Y equals A that's the 40,000. 1 plus your rate, 3.35%, and it's happening for 12 years, but it's happening every 2 years. So what we have, and $40,000, and let's look at 3 3/5%. So 3/5 is 6/10, which is 0.6. So that's 0.036. Again, the decimal moves 2 places to the left to give you decimal 0.036. So that's 1 plus 0.036. And if it happens every 2 years, it means it's going to happen 6 times. So that's 40,000 and 1.036 to the 6th power. And that comes out to be 49,456. So this is 48, this is 49. This is the best one so far. Right here, it gives you more salary at the end of 12 years. And what about 2% every year? Well, your rate is 2%, and your C is 1, because every year is 1 year. So your formula Y equals A, and 1 plus your rate, T over C. So that's 40,000. 1 plus your 2%, and it's 2%, and it's happening 12 years, but it's happening every year. So that's 40,000 and 2%, and that's 0.02, and 12 divided by 1 is 12. So inside your bracket is 1.02. It's happening 12 times, and that comes out to be 50,730 when you plug it in your calculator. And as you can see, you have different options, but the best, even though this is the lower percentage compared to these three, happening every year is compounded, so you're getting more salary on your salary. So the better one is the 2% every year that gives you $50,730. So this is the best choice. Again, just more problems to help you understand what compounding interest compounding is doing in exponential growth problems. And if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.